Welcome. So today we're going to be graphing sine and cosine graphs with multiple transformations. So we'll have amplitude change, period change, phase shift, and vertical shift. All right, so here's a list of all of our steps. And these are all the steps to graph any kind of sine or cosine graph. And you could use these steps anytime you're graphing sine or cosine, and then you could skip the steps that you didn't need to apply. So for instance, if there's not a vertical shift, you would skip step 8. Okay? All right, so let's go through our steps here, because actually we're going to need to use all of these steps for our equation here. So we want to graph y equals -1 plus 2 sine, in parentheses, 4x plus pi. Step 1 is we need to factor out b. b is the coefficient in front of x, and if it's inside the parentheses, we need to factor that out. If we don't factor out b, our phase shift will be incorrect. All right, so we have y equals -1 plus 2 sine. I'm going to factor out the 4, which means I'm going to divide 4x and pi by 4. If I divide 4x by 4, I have x. If I divide pi by 4, I have pi fourths. All right, so step 2, we want to identify the amplitude, period, phase shift, and vertical shift. All right, so let's identify our amplitude first. Amplitude is the coefficient in front of sine or cosine, and it is the 2 right there. So our amplitude equals 2. We find the period by dividing 2 pi by b. We've already factored out b, so we've identified that b here is 4. All right, so we're going to divide 2 pi by 4. So that gives us pi halves. Right? So pi halves is our period. That means it takes our graph just pi halves, 1/4 the normal cycle, to go through the entire cycle, to have all of its values, maximum, its minimum, its x-intercepts, and everything in between. All right, so now we want to identify the phase shift. Phase shift is what's in parentheses. It's what's added to x, and the sign is the opposite. So if we have a plus pi fourths, this is a pi, looks a little crooked there. That means that our phase shift is negative pi fourths, or left pi fourths. So we're going to go pi fourths to the left. And lastly, our vertical shift. Vertical shift is what's added to the whole function. It could be in the front or in the back. So it's not attached to sine. It's not being multiplied by sine. It's not in parentheses. It's just something else that's added or subtracted in. All right, so our vertical shift is -1. Be down. So the sign is the same as you would think it would be. If it's negative, it's going to be, the function will go down. If it's positive, the function shifts up. All right, so our vertical shift is down 1. Okay, so we've identified all of those things because we want to remember which things we have to do. Okay, so if we see we have an amplitude that's not 1, if the period's not 2 pi, if our phase shift isn't 0, and our vertical shift isn't 0, that means we need to do all of these steps that come below it. Okay, and sometimes we'll only need to do some of these steps. At a minimum, we would at least need to identify the 5 key points, step 3. And that would be the absolute minimum if we have no phase shift, no period change, no amplitude change, and no vertical change, no vertical shift. All right, so step 3, we're going to identify our key points. And I'm actually going to put everything else, I think, on the next page. Because I have a table there for me, and I'm going to start to run out of room. And I have my graph on the next page anyway. All right, so I think I can remember these things. I'm going to switch pages. Plus, I still have the function written up here anyway. Oh, I have the same page twice. Okay. Let's get rid of that page. Don't need it twice, only need it once. There we go. All right, so let's identify our max and our minimum values. For sine and cosine, they occur at 0, pi halves, pi, 3 pi halves and 2 pi unless there is a period change. I need to fix this. I cut and pasted from yesterday and I forgot that I accidentally wrote phase when I meant to write period. I already have phase written there. All right, we do have a period change. Our period is pi fourths, or excuse me, pi halves. Let me fix that. It's a little hard to read that. All right, so our period is pi halves. All right, so that's how long it takes to go through the whole cycle. Every fourth of the way, we go through something important, either an x-intercept, we have a maximum or a minimum. So to find where our important points occur, we just take our period and divide by 4. Okay? So our important points, those key points, occur at pi halves divided by 4. And dividing by 4 is the same as multiplying by 1/4. So they occur every pi eighths. All right, so now to find my new x values based on the period change, I'm going to always start at the beginning at 0. And instead of going up by pi halves, I'm only going to go up by pi eighths, because that's how long it takes to get to the next thing, to get to the x-intercept or to get to the maximum or minimum values. So if I count by eighths, I've got pi eighths. I have 2 pi eighths, which is the same as pi fourths, 3 pi eighths, and 4 pi eighths, which is the same as pi halves. And this will always match your period. Okay. All right, so now we have our phase shift. Actually, I'm going to do the y values and the amplitude, and we'll graph the base graph. Then we'll come back and we'll do the phase shift and the vertical shift. All right, so our y values that go with our key points for sine. Remember, sine starts at 0, and then it goes to 1, 0, -1, and 0. We have an amplitude change. Remember, our amplitude was 2. So we're going to multiply all of these values by 2 to get our new y values, because our graph has been vertically stretched by a factor of 2. Our graph has been horizontally shrunk by a factor of 4, and it's been vertically stretched by a factor of 2. All right, so if we multiply 0 by 2, we get 0. 1 by 2, we get 2. 0 by 2, we get 0. -1 by 2, we get -2. And 0 by 2, we get 0. Okay, so let's graph that one. I'll graph that one in blue, and then we'll do the phase shift. All right, so my first point, and I'm going to use new x from the period change, new y from the amplitude change. All right, so I'm going to start at 0, 0. And then the next point is pi eighths 2. I don't know if you can see, but that right there is pi halves. And so these are 1 pi, 2 pi. Gosh, what are they going up by? I have no idea. Nothing really normal, though. But half of that would be right there. That would be pi fourths. And then half of pi fourths, which it's not this line because there's only 3 of them there, and there need to be 4. Let's move that line over. You know what, for the sake of simplicity, and so that you can actually see this graph, I should have put a different coordinate grid up here. Let's just call this instead, do we have enough room to call it pi eighths? Let's see, 1, 2, 3, yeah, we could call it pi eighths. All right, so this is going to be, now this is pi eighths, and now that means this is 2 pi eighths or pi fourths, and this is 3 pi eighths, and this is pi halves. There we go. So if I ever give you a grid that just really difficult to work with your points, then just to change them like that. There you go. Now it'll fit. All right, so now we can graph this. All right, so 0, 0, pi eighths 2. All right, so this will be 1, and then that means that's 2, -1, -2. If I didn't change that scale a little bit, you wouldn't even be able to see this graph. It would be so squinched. All right, so pi eighths 2, and then pi fourths 0, and then 3 pi 8's negative 2. And then pi halves 0. So here's the untranslated graph, just the period change and the amplitude change. And you see, and of course, the more I stretch out those values there on my horizontal axis, of course, the more stretched out my graph looks. But in reality, I'm just representing it. And I can make the space be whoever I want so that I can actually draw it in. Just like you can number by anything you want when you're graphing any other function. So long as the values are consistent, you're representing your function. All right, so now let's take care of the phase shift and the vertical shift. If you remember, the phase shift was pi fourths, right? It was pi divided by 4 or pi fourths. So we're just going to add pi fourths to each of these. So if I add pi fourths to 0, I'm going to have it's negative pi fourths. Negative pi fourths, sorry. It's pi fourths to the left. Almost forgot, we need to subtract pi fourths. So that gives us a negative pi fourths. Pi eighths is the same as 2 pi fourths. And 2 pi fourths minus pi fourths is going to give us positive pi fourths. See if that something seems 0 minus pi fourths is negative pi fourths. 2 pi fourths minus pi fourths is pi fourths. Okay, no, looks okay. Yeah, and our graph. All right, pi fourths, yes, minus pi fourths, that's 0. What did I just do here? Oh, why did I do that? Oh, my goodness gracious. Pi eighths is not 2 pi fourths, that's pi halves. Oh, I'm losing my mind. I need to change the pi fourths to 2 pi eighths. I knew I did something wrong. In my defense, it is late, and it's dark here, and I want to go home. There we go. All right. So pi eighths minus 2 pi eighths. At least I recognize something looked wrong about that. Gives us a negative pi eighths. Right? Because this is what the values are going up by, right? They were going up by pi eighths, right? We counted pi eighths, 2 pi eighths, 3 pi eighths, 4 pi eighths. Even when we shift them, they're still going to be pi eighths apart from one another. All right, so pi fourths, negative pi fourths, negative pi eighths, so we're just counting up by pi eighths here. And then pi fourths minus pi fourths gives us 0. 3 pi eighths minus 2 pi eighths gives us pi eighths. And of course the next point is going to be 2 pi eighths or pi fourths, right? Because we're counting up by pi fourths. So 4 pi eighths minus pi fourths is what we're doing, and it's going to give us pi fourths, or 2 pi eighths. Oops. Now I went to write 2 pi eighths instead of pi fourths. All right, so that's going to be our x values. We've just added, or actually subtracted, pi fourths from all of our values from the period change. Right? It's sometimes a little difficult to count it on the coordinate plane, right and left. That's why I usually like to make a column. And even if you do count it, the column gives you something to check back to. So if something doesn't seem right, you'll catch it either by counting or by writing the values down. So it's kind of like a checks for yourself. All right, then the last thing is the vertical shift. The vertical shift is pretty easy. We have vertical shift of -1, so all of these values are going to change by 1. They're going to go down 1. All right, so 0 minus 1 is a -1. 2 minus 1 is 1. 0 minus 1 is a -1. -2 minus 1 is a -3. And 0 minus 1 is -1. All right, so let's graph our values, and that's about it. All right, so we have, now I'm graphing phase shift and vertical shift. The only thing is I have no values. This could not have been the graph. I probably just grabbed this graph and said, oh, that's a nice graph. I'll just take this one. So 1, 2, 3, This would be pi 8. And then let's continue my graph here. 1, 2, 3. So I'm making negative pi 8. I'm making do with what I have here. So I should have taken a different graph, one that had some values on the left-hand side there, because my graph is shifting to the left. All right, now I can graph. Negative pi fourths, negative 1 would be right here in the middle of the pi symbol. Negative pi eighths, 1 would be over here. There we go. And then we've got 0, negative 1, so that would be over here. And then we have pi halves, negative 3, which would be right here. This is good on the x and y's. And then I have enough values there going vertically. And then pi fourths, negative 1. And there was one last thing we forgot to do, and let's do that before we graph our function here, and that is to graph our midline, right? So the midline is just the value the graph is oscillating about, and it's the same as the vertical shift. That's why we see all these negative 1s. These were originally the x-intercepts. Now, those values are crossing our midline. So our midline is y equals negative 1. I'm just going to graph that. And that'll help me make sure that my graph is in the right place. And then finally, let's just connect our dots and we can see our sine function. And there it is. So you can see that graph that we originally drew, the blue one there, is just shifted pi fourths to the left and shifted 1 down. And let's just give our domain and range, and then we have all of our steps. Domain is never going to change. It's negative infinity to infinity. Our range, because of the amplitude change and the vertical shift. Our low value, and you can see it in our graph, it's in our table here, it's our minimum, negative 3. Our high value is 1. Okay? And there we go. And so notice there's a difference of 4 between those values. Right? And that's because normally there'd be a difference of 2 from the lowest value to the highest value, except our amplitude is 2, so now those values are doubled. Okay? So we've gone through all of our steps. So just to recap our steps, I'll go back to the other slide there. Okay, so after we identify our amplitude, period, phase shift, and vertical shift, we identify those 5 key points. That's when we filled in the 0, here it comes someplace, sometimes here we go, the 0, the pi halves, the pi, the 3 pi halves, the 2 pi, and the 0, 1, 0, negative 1, 0. Those values go together. Those are the max, minimum, and x-intercepts for sine. All right, and then after that, we use the period divided by 4 to identify the new values. So that's where we counted by, we started at 0, and we counted by pi halves divided by 4, or pi eighths. Right? And we counted 0 and pi eighths and 2 pi eighths and so forth. Then we multiplied the y values by the amplitude to find our new y values, and that became our base graph, without the vertical or the phase shift or the vertical shift. Okay, then we added the phase shift to the new x, that's to the period change. We added the vertical shift to the new y, the amplitude change. We graphed our midline and translated our base graph, and then we gave the domain and range. And that's all our steps. So once you get the hang of it, it's really not very difficult because you do the same steps over and over again. This is as difficult as this graph could become. There's nothing more complicated I can do to this graph. So if you can graph this one, you can graph sine and cosine. Let me see how many I have. I may do one more on this podcast. I'm at 20 minutes. Or I may do one in class. Let's see how many I have. I have 1. I'm going to save this one right here for class. All right, so I'll save that one for class. This one I did on the podcast. All right, so let's look at, I'm going to actually make this my next podcast. So I'm either going to make this a podcast. If you see a podcast that says tangent, you know I made a podcast. Or I'll do this one in class tomorrow. Okay. All right, so that's the end of this tape. And so come back for tangent. All right, bye.